Hello everyone, I am Bradley Sward, Associate Professor of Computer Information Systems at the College of DuPage in Glen Ellen, Illinois. And this video today is going to take a look at functions using C++. So what are we going here? I have Visual Studio already up and running, and the first thing you notice if you have just a basic hello world minus hello world kind of problem staring at me is that I'm already using a function. The main function is already here, and outside of the fact that the main function is required by the language and it's the first function that gets run when your program starts up, there's really nothing outside of that that's too special about it. It follows the same exact rules when it comes to what the return type is, what the parameters are, what its name is, and its function signature and then the body of the function. So just keep that in mind as we go forward, that main isn't really anything special. So modular programming, functional programming, is taking a program and breaking it up into smaller and more manageable chunks. And that's why we don't just, that's why we put spaces between words, and that's why we put paragraphs, writing papers and just writing our ideas out. We don't just jam everything into just one wall of text. At least we're not supposed to. And programming is the exact same way. We're supposed to kind of take our thoughts, how are we solving a problem, break it down into its its component parts, and simplify the process. And hopefully you do that in the engineering work that you guys already do, or just whatever other kind of math or science or reading, writing, whatever it is you're doing. Hopefully you're already taking a large problem and breaking it down using a top-down design to make it work. So a function is, at the end of the day, a collection of statements, an algorithm that solves a specific task. And we all fall for this, where it's supposed to be, a function is supposed to do one thing and one thing well, but we all kind of fall for it, and we all kind of just a lot of times combine different tasks into one function item. And it's just a matter of how far do we need to break down our problem to get the job done. And then once you understand that, how do you future-proof it? How do you make your code able to handle maintenance and future proofing? And that just takes experience. There's nothing about that I can teach you right here, right now. And so, of course, maintainability is improved if I need a cosine function, right? Something like that. What if instead of using a cosine function, I wrote the code for handling a cosine, and every time I needed a cosine, I just popped all that code in there hundreds of times for a video game or something like that, because cosine is used quite often. It's cosine, sine, all that kind of arctangent, stuff like that. And what would happen, right, is that if there was an error in my code, or if I copy paste something incorrectly, well, I have a huge problem. And so it simplifies things if I can just write the code in one place, the actual code that does the work, and then refer to that code whenever I need to. And so I only write it once and I can use it forevermore. So that's the whole idea pushing forward of what functional modular programming is all about. So this is just another explanation of that, of just taking int main that has just a ton of stuff going on for it and breaking it down into subparts that each of these functions have specific goals and specific purposes. So again, we know how to do this because we've used main, we've actually used object-oriented programming with cout and cin, we've used functional programming anytime we're using CMath or any of those other IO manip or any of those kind of functions. We are using other functions. And so this, let's see, a function call, which, so like cosine of 0.32 or something like that. And so the statement causes a function to execute. It goes in and passes this value into the function, and it applies this value to whatever function, f of x equals whatever, cosine of x. And so x goes in and y comes out, or cosine of 0.32 comes out. And so inside of here somewhere in code somewhere, there's a function that just does something like this. And then it returns the cosine, just whatever, who cares? I'm just saying, it returns a value. That's kind of what we're going for here. So this function calls this guy to do the work, and then it returns back, and then it goes on like nothing ever happened. So as you can see here when I wrote this out, there's a few things you have to account for when you create your own function. Let me just create my own absolute value function instead. Double in, double out, and It's not like an if statement is the hardest thing. I'll use an if statement in here in a second here. But what do you see here? What are the it's called function definition, function prototype, all these kind of things. There's lots of different names for this. And they say, okay, there has to be a return type. And the one thing you notice here in C++ is that the return type is the first thing that gets popped up here. So the return type is a double. The return type is an int. And I can actually have a function that doesn't return anything, and that's called void. And so, like print menu, if I just had a function like this, so I could return anything. I can only return one value. This isn't Python where you have this illusion that you can return multiple items from a function. You only can return one thing at a time. Double, int, void. Void doesn't technically return, but you can't just leave it blank. And so that's the first type, return type. Then the name of the function, print menu, absolute value, main. Again, main is the only one that has to have a specific name, and it has to have a very specific function signature. And then the parameter list. Main and print menu in these cases don't have any parameters. There's no inputs to this thing, but the absolute value function absolutely does. Right? So it has, I can pass in the x value to this thing, one parameter, and you could pass in one thing, 0 things, or many, many, many things. I've seen functions with 11, 12, 13 parameters over the years. And it depends on what the function's job is, and it depends on what the function needs, what kind of information it needs to do its job. I mean, I only need one piece of data to calculate an absolute value that's outside of what the function can do. And so you're like sculpting down to what is the minimal amount of effort that goes into solving this problem every single time. And then once you have that, how can I make it more efficient? And so then, of course, the final part is the body of the code. What goes inside these curly braces is supposed to be what obeys and follows the rules. So for like an absolute value function, I could say if, so again, we haven't really covered it depending on where you're coming from, but if you haven't, there's nothing too complicated. You say if x is less than 0, then what do I want to do? I want to say I want to negate x because I want a negative value should turn positive. And then at the end of the day, I'll return x, whatever happens. If this doesn't happen, if I don't call the code to go inside here and negate it, that means the value is positive. It was 0 or 1 or 2 or beyond positive. And so there's no need to negate the value, but if I do negate it if I need to, and then I return back the value from this function of this x value negated. So that's the body of code. Or in this case, if I do cout, just say menu, I'm not going to write out the whole thing. I don't want to waste anybody's time. But the whole point of this is just to write menu, cout, 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 cout. Well, that's what would happen if I called this. I could call this and say, okay, print menu. And then I can go ahead and say cout absolute value of -9 with an N. And so you can imagine then, hey, no compiler errors. So you could see here, so what happened is this function gets called like any other function, print menu calls, it prints out menu. And then when it comes back, when this is done, it comes back to here, comes to here, calls absolute value function, does its job to calculate -9's absolute value is +9, returns back and prints that value out, because this is an integer at the end, or double at the end of the day. Should probably do it correctly. 9.0. There we go. The same result because of the formatting, but you get the point. And then it comes back from this, prints it out, and then that's our whole thing. That's the whole job of everything. And our main function looks a lot more readable. It's not just splotches of code just kind of thrown in. It's more readable because now in more human readable, in English, in something human readable language, I can see what is supposed to be going on here. You see in this example then kind of the same stuff as we did before. I can do anything. A function, it technically doesn't have to exist, but it's here for our convenience. It's here to make our lives easier in the long run. So like in this case, why would I put one line just like I did for this menu? But again, if I'm going to be printing this out multiple times, why would I duplicate my code? Why would I have 5 or 6 lines of code in 7 or 8 places? So I can print out hello from main, then I can call this function to call hello from function display message. So that would be the second thing that prints. And then when I come back, it knows to come back to here and continue on. And so back in function main again. Oops, I thought they could show us the output of that. But you could imagine then that that's what's going on. This prints first, then this goes in here to print this, and then this comes back and prints that. So We're not used to control. The flow of our program is usually top to bottom, but now this is where the term spaghetti code starts coming from, because a lot of times you can kind of get into a situation where this code calls this and this and that. I like to call it Duck Dodgers in the 24th and a half century, if you've ever seen any of the Bugs Bunny cartoons from way back in the day, because it just it goes all over the place. Your code, you think your code is just pretty nice and straightforward, but the reality is everything's moving around all over the place. So the compiler has to know what's going on. The whole reason we're writing code with a very specific syntax is that the tool, the compiler tool, has to know what's going on and has to be able to break things down. It can't infer, it can't guess. It can only follow the syntax rules that has been given. So main can call any number of functions. Any other function can call any other number of functions. And so the compiler needs to know. That's why we call it a function prototype, because all of these details the compiler needs to know. It needs to know a name, absolutely. It needs to know the parameter list, the return type. And then if you want to even think about it, the code could even come later. If you want the code, because it's just, when it comes down to it, it's like a little black box. It's like it doesn't, who knows what goes on inside there most times? I don't know how cosine works after 20 years of being in the business here. So, and you don't necessarily have to either unless you really want to delve in and figure out what's going on. Okay, so function prototypes. So this is kind of a big deal. This, notice everything ran perfectly fine the way I had it right here. But what if I took these two functions and I brought them down under main? And so what happens here, I'll build this, and what happens is print menu identifier not found, absolute value identifier not found. And this is where frustration can set in sometimes with programming on the compile side, on the link side, because you're staring right at it. I go, what do you mean not found? It's right here. It's right here. But what happens when our program is compiling, it's going top to bottom. And so it's going through pound include, pound include, pound include, pound include. Here's using namespace SCD main, but when it gets to here, it says that, oops, there's nothing called print menu. Just like if I tried to use x equals 4, and then later on I said int x, it's the same kind of deal, but it's talking about functions instead of variables. So it doesn't know it exists yet. So the idea of function prototype is a way to allow us to write code this way and not have that error pop up in it and allow this to continue forward. And why do we need to worry about this is because, as I mentioned a minute ago, when functions can call other functions, which can call other functions, you will reach a point where your file, there's no way you could put the functions in your program without one of them calling something that hasn't been defined yet. So there has to be a way to kind of give the compiler a placeholder and just say, trust me, you'll find it somewhere in this file eventually. And that's what the idea of a function prototype is all about. It's a way to notify the compiler that there's a function that exists prior to actually using the function in your code. And so all you really do, if you write your function first, you just kind of steal the top line of this and just bring it up to the top of your file. So I can do this for both. This is pretty much, that's it. Boom, done. Function prototypes have been installed, and now this will build. So everything has to be an exact match, and this is, I call this like trust me, or something like that, where you're promising the compiler that somewhere in your code you'll find this. It'll be called print menu. It'll have no parameters, and it'll have a void return type. And so when it finds this, it goes, oh, I trust you. You told me it'll be there somewhere. And then when it gets down here, you go, aha, there it is, and it fills in the gap. And so what will happen if you forget to actually, this is where we call linker errors pop up, not compiler errors. Because now I have, say compile just fine, and now these unreadable linker errors pop up. And that's because our programs can be composed of more than one file. And when that occurs, by telling me I'm going to find this somewhere, that tells me I'm going to find it somewhere in my entire project. So on a file basis, this works just fine, because you told me somewhere in this project you will find this guy, and then I'm using it, but when it comes down to it, at the end of the day, when I bring everything together in the end, I can't find it. And the linker says, I don't know what you did with it. You promised, but you have not delivered. So you just got to be careful for a few of those things as things are going on here. So you can see void first with no parameters, void second with no parameters, and And again, if you just, for the stuff we do in class, you really don't have to worry about this too much. Just put the functions before main, and you're pretty much good to go. But this just out in the world, and once we move over to object-oriented programming anyway, this kind of falls away because you don't really worry about functional programming in an object-oriented paradigm. So just to say, this is just a kind of a temporary thing until we move up higher toward the end of the class and beyond. Okay, so again, place them near the top. I like to put them right here. I like to do my includes, my using namespace if I'm going to be lazy about things, and then I like to put my function prototypes and class prototypes and things like that there. But it has to be an exact match. You'd be like, what's the difference between double and float? Well, everything. Because it has to be an exact match when it comes to data types. Just because you can convert a float into a double or a double into a float doesn't mean the compiler will. So you see the error here. And let's see. And you can put the prototypes in any order because the prototypes do not rely on any other functions to project the information they project. Alrighty, so we've already kind of covered here the idea of sending data into a function, but let's continue on. We need to know for each function, we need to know how many parameters are being passed in, we need to know what it returns, and most importantly, we need to know what it does. So like a lot of times, almost always, the function name pretty much goes with the thing it's trying to do. So power function, a comma b, well that would tell me I'm trying to take a to the b power. That's kind of what I see there, right? You guys, if you don't have that access in a calculator, you're using some kind of function to get the job done. So just when it comes to the way that the terminology is here, on this side, on the main side, this is called an argument, and so this is the values that will be passed into the function, and then down here in the function itself, these are called parameters. And to me, I just call them all parameters all the time because I mean, what's the reason to have two different? I kind of get it, but there's no true reason. Just parameters, arguments, parameters, whatever. It's the same kind of difference. And just understand that there is a technical difference in the terms here. And so this -9 will get passed into the x value here. And just like in this case, the int num, I have to pass this value in. I can't just say, give me absolute value of nothing. This will not work. See, the compiler error comes up. Or I can't say print menu and just put my name in quotes or something like that. Because what I'm trying to pass in doesn't match in with what the function must be passed in. So everything has to be a match. The data types themselves can sometimes not match up in that coercion idea. So like a lot of times we'll need to static cast things if we need to convert from one data type to another, just to ensure that the program is operating properly. So again, I can have 0 parameters, 1, 2, 3, 4, and beyond when it comes to that. And if I do have more than one, notice it's a comma b. Like there's no way to know if I put the values in reverse and put b comma a, there's no way the compiler is supposed to know that I reversed them. So you have to make sure that you understand you put everything in respective order the way that the documentation tells you to go ahead and do. So I have a void function called display value, takes in an integer. They don't say their function prototypes are a little different. Like I totally recommend putting names for them because especially when things get more complicated, you need to know. If I just put int, comma, int, comma, int, comma, int, comma, int, how do you know what you're supposed to put there? And so some people will do that. I think that's totally lazy and totally not cool for people using that code. Because how are you supposed to know what each of those 5 parameters are? What am I supposed to, I mean, it's pretty simple to determine what this is supposed to do here, but anytime this is more complicated, it can get more complicated. So display value 5, here's my function. So the 5 gets passed in, and it's 5 on this end, but over here it's num. And so 5 will be set into num, and then when it goes, the value is 5. And that's exactly what's happening. A copy of this value is being passed along to this, so it'll print the 5 out. And we'll talk about the 2 different ways we can pass information into a function here in this video in a couple slides whenever we get to that point. So again, 5 is what's on the main side, that's the argument, and then the 5 gets passed into variable num, and on the function side, we use num as the parameter, and in this case, that parameter is set to the value of 5. So let's see. for each function argument, the prototype, the header, all these kind of things. Again, just watch out, because sometimes, like we were saying, when it comes to the prototypes and all of this stuff, everything has to match up exactly. But when it comes down to it, this will still work. See, no compiler errors, no compiler warnings. So this is negative 9.0 float that gets passed into this function that handles double data. So this will actually change the float into a double on the fly. Again, we call that coercion. We call that casting. So it's like, so you just have to watch out for that. Because what if it was the other way around? What if this was a double value and I was transferring it and changing it into a float? I'd be hacking it down. And we showed in the last video that the compiler is completely happy chopping things down and ruining your life when it comes to removing the values that you're supposed to have. Okay, so the key here is that we're actually passing a copy of the value when we, versus like the real data. We'll see this in a couple minutes here, because if I had something like this, float, or double F equals, or double D equals 9.0, and say pass in D, it's not passing in, what is it passing in, right? It's passing a copy of D. So we're going to show here in a couple minutes that when this kind of code is run, there's two separate copies of the value 9 sitting in your memory. There's the 9 that's sitting on the main side, and then when you move over to the function, there's a copy of it that's being used on that end. So that's what this is saying. A copy is being made, and the parameter, the scope, is to say, okay, that's an interesting one. Yep, we haven't talked about that. So this x can't be used outside of this function. So the scope of this variable is the function. When it hits this closing curly brace, it no longer is part of the deal. It has now basically gone off to pasture here. So your function can have multiple parameters, and it all depends on what you're trying to get across. All the parameters have to go into the parentheses, even if there's nothing, right? Even if it's a void function, or I was saying there's no parameters in here, you have to use open and closing parentheses to get the job done. And as we just showed here, the arguments, you got to be careful for this, as we just said, that your arguments will be promoted or demoted as necessary, as best as it can, to match what it needs to do. Sometimes it still can't do it. It can't convert a string into an int or things like that, but it will do its best to try to do what the intention of what you want, and a lot of times that intention still can go wrong. And so when you say everything is in respective order here, let's find this here. So again, if I passed in multiple values into a function, that the first value as the argument gets passed into the first parameter in the function. So that makes sense, right? That everything is in respective order, left to right, as we're going through and figuring out what's going on. And so that, again, sometimes, like for this function, it really doesn't matter what order you put the variables in. But for almost every other function you deal with, yes, it very much matters the order of the parameters to your function, and not just this because it's int, but sometimes you have different data types and all sorts of things are going on, and you have to make sure that the function gets the data the way it needs to, because as everything else, garbage in, garbage out. So even though it compiles, it still might not work for you. Okay, so here we go. This is our first discussion. Today we will discuss there are two different ways to pass information from a function to another function. And we've already done one, and that's this one, pass by value. So I use the Xerox copier analogy when it comes to what's going on when I pass information from function to function. So when I pass something by value, which happens the majority of the time, especially in this course, is that when an argument is passed to a function, its value is copied to the parameter. And so in that case, because I'm going to the copy machine with my value D here, 9.0, 9, it's sitting on a piece of paper. I go to the copy machine, I put it down, I hit copy, and so now there's two separate copies of this data. There's the original one that's in my hands, and then there's the copy of it that's now sitting, on the printer. And so now what happens is, when I call this function off, I go to the printer, I hold on to the original copy, and then I give you the copy. And so what happens, just like in anything, if you gave someone a copy of something, They're free to do with it whatever they want. They never have to give it back to you, so there's nothing for you to worry about. That's their scratch paper. They can ignore it altogether. They could just look at it. They could write all over it and change it. They can do whatever they need to do, but it doesn't affect me because my copy, the master copy, still is sitting there perfectly fine as the value 9.0 sitting under the hood. So changes inside of the function like this does not affect the end value, because you might think that when I pass d along as 9.0 and let's make it -9, you might think that by changing this from -9 to +9 that I've changed this value from -9 to +9. But let me just assure you that that is not the case. And so I can see out d with an line. I can print out absolute value of d, and then I can print out d again. Right? I mean, I think that's a pretty good thing. You know, it's like print out the value, use the value, and then print it again and see what happens. And you will see here that you get that menu thing. And you can see that -9 is the first value that's printed because you expect that because that's d is -9. But when I pass this along, -9, and I go in here and I convert that -9 into +9 and return the 9 back, you would expect +9 to come back because that is the return value of my function. And then the third one here is now printing, since now it's all said and done, d was modified in the function, but when I go to print it another time here, you notice it's right back to -9. And that's because you might have changed it over here. And even if I put another c out right here, it'll print +9, because that's what x value is. It's returning the positive value. But now, coming back on the other end, my master copy is the only thing that matters on the main side, and that is still holding the value of -9. And so all of these slides are just basically explaining that idea, and it's a very powerful idea because you want to make sure that that your data is being manipulated in a way you're expecting. And in this case, I want to make sure that I'm just asking you what the absolute value is. I'm not asking you to change it. And we'll show here in a couple minutes that how would I want you to go? How could I set up a way so you could modify the master data? And that's the second methodology today. Okay, I guess that was it. I mean, so this happens the majority of the time, like 90+% of the time, we're passing information by value, passing copies of things along, and it's not really a waste because you do have to pass information from one place to another, and for the base data types, ints and chars and shorts and longs and those kind of things, it's pretty much exactly the same amount of time to pass this information as if it were to make a copy. So you don't have to worry. The copy is a perfectly legitimate thing. But we'll see in further examples and later on, and if you move on into advanced C++, that that's not always the case. And so a lot of times we have to tinker with our code to make sure we don't pass along thousands of bytes of data, that we just pass along information master copies instead of copies of copies, because things get obviously much more complicated. I'm not sure exactly why this section's here in the book where it is, but why would, we've already talked about why functions can be used, but there's no reason not to kind of reiterate just for a brief moment here and just say, why would we need to use a function? A function is there to eliminate duplication of code and to basically take code, like this absolute value function, and reduce it down into one place. So if I ever needed to fix up the code, this is pretty solid, but if there was ever a need to go in and say, oops, there's a bug in my program, there's a bug in the absolute value function, there's only one place I have to go fix it, and then it propagates through and it works for everybody else. But if I put this code in here, in hundreds and hundreds of places in my code, and then I find there's an error, you can imagine where that's, what this is, where that comes from, where the errors might come from, because how do I know exactly how many times that code is in my project? For thousands and thousands of files, I don't know. And if I forget one of them, I still have a bug in my program. So you can kind of get the point of what we're trying to do here. We want to write code one time, and so we can be lazy about it and use it forevermore. And that's the idea of a general purpose task. High-level functions that call, higher-level functions that call lower-level details. So, because we would love to write code that is, I wish I could just talk to the computer like on Star Trek Next Generation, or like talk to my Google and just say, hey, well, I'm not going to say it, but just say, hey, can you help me out? and just start talking, and it can write code for me. Wouldn't that be amazing? But that's just not how things work. So, but we're getting closer to that high-level code to work its way down into low-level code that actually does the work that we want it to do. And so a menu item, again, is the same kind of thing. If I'm going to print this more than once, or even if I'm going to print it once, print menu looks a lot better inside of the main function than all of the code that would go in there, all that ugly, ugly code. So once you get used to this a little bit, the main function especially should become much more human readable. And so as you're writing correct names for functions and using variable names that instead of D, you can use whatever you need, like choice and things like that, you can see that, like at a high level in main, yes, it looks a little more human readable, and we're just trying to reduce the amount of time we stare at the real code. We're trying to add structures to our code that make things easier for us to look at. So I'd say we've already covered the return statement, but it doesn't hurt to kind of give it a little more detail. So what happens here is we have our main function. It doesn't take in any parameters, but it could, but it returns an int. And this kind of falls back to the old days and even the current days when programs are run in a batch mode from a command prompt. And maybe I need to return that something went wrong from a specific function, like if I'm doing credit card records or who knows what. And so the main function returns 0, in this case saying nothing went wrong. And say in a GUI environment, in a modern world, we've kind of changed the way we do things, so we don't really pass in parameters. We double click on Excel, and then we open our Word, or we double click the item itself, which is basically opening up Excel with the parameter for the file that needs to be open. So there's newer ways to go about doing these things. So the main function is one of those things that kind of is keeping to its old roots because it needs to, because certain people, especially running on Linux servers, and just there are reasons for these programs to return values. So the main can neglect a return. I don't know why do I tell you all these things, right? And it's like, do I get a warning out of that? Not even a warning, right? So main is the only function that does not have to have a return 0, but you have to do that because that is portable code. So return 0, but notice like my void function does not have any returns, and if I tried to return anything, I'll get an error because return value does not match the function type. And so for any other function, say I could get rid of it for main, but if I neglected this, you would get at least a warning. I hope you get an error, but okay. At least this time it says must return a value, okay, which is fine. And then if I put, I don't know why that, if I just said return X here and I did this again, you'll get a warning this time that says not all control paths return a value. Because if I go into here, I return, but if I don't, what do? I don't return anything. And I don't know why that's not an error in itself, right? It seems like that's a very big deal, that in some cases it'll return a value, and in some cases it'll return garbage or nothing at all. So just be careful with that when you're dealing with this, because there's a big difference between doesn't return ever and only return sometimes. And so anytime I hit a return, and you'll see this when we go and add breaks and returns and all sorts of stuff later on in more deeper code, when I see a return statement, it's basically telling me I'm done, that no other code will run. Will this give me a warning? Unreachable code? No. But this is unreachable. When I hit return X, I basically hit the closing curly brace and I'm done. So in this case, the X equals 4 will never be run ever, ever, ever. And if it is, it's a huge problem anyway, because then your compiler is just garbage. And so you can have a return anywhere, but again, watch out, because if you know what you're doing, that's a great thing. But if you don't, that's not great. The return should probably be the last line of code that you've got going for you. And so, and when you say what we're saying here, with this function that doesn't return, it technically does return when it hits this closing curly brace. So it's like it does, but so the return is implied. And you could, why am I showing you this again? You could put a return like this, but I'm gonna give you some comments on that, because why would I need to write more code when it's gonna return here anyway? So just be careful for that. So here you got divide double double, void double double. The main returns an int. The divide does work but doesn't return anything. Okay, so I mean that's all, and our function takes in data and returns data. And this function takes in nothing and returns nothing. And this one takes in nothing and returns an int. So there's all the different ways you could go about doing it, right? I don't know what kind of function would take in nothing and return something. Maybe a rand function. Give me a random number, and I'll give you one. 19, 22, 614, that kind of stuff. Like maybe you don't need to pass in data when you're like, give me a random number. Who knows here? So we've already done this too, returning a value from a function. We've already discussed that. It's like, so it's just the output. And again, coercion rules apply if it's trying to make sure, if you're trying to return a double, make sure you put it into a double space, a variable or something that is a double. And so a function can return a value back, of course. You've already used the power function, and we've already used absolute value, double in, double out. And so again, we have to watch out, because what if I did something like float f equals absolute value of negative 3.1. And this is a double. Double goes in, double comes out, but double will go into here. And so we'll actually see how it's 3.100000000, lots of zeros. But if I run this program, you will see that the value has actually been modified here, and it's 3.099999, which is not even the same, right? It's on the other end of 3.1. So again, that's the closest value we can get, but we have to watch out for that. Coercion rules, and the compiler will not give me a warning, will not give me an error. It will just blindly change from double to float. There's a lot going on in the C++ language that forces the programmer to kind of know details that other languages don't make you realize, because there's just too much to, nowadays, 2020 and beyond, there's just too much to know for every individual language. So let's see, the return statement, like in this case, this could all be put into a one-liner. There's a lot going on here. Double result, result equals num1 plus num2, return result. You could just say return num1 plus num2, because it's just the addition of an int to an int gets me an int, and I can return that. So just don't do code like this, guys. Don't do code like that. But you get the point here. It's everything all in one. I can take a value, do my work, and get done with it. And so, again, int in, ints in, int out. And be careful, again, between floats and doubles and all sorts of stuff when it comes to that. And it's a lot for one little simple function for some, but you get the point here. Two values come in, and they actually fixed it up here for the final. Good for them, at least, that they return just num1 plus num2. Try to reduce your code, especially for returns. There's no reason to have 2, 3, 4 lines of code when it's something as simple as this when it comes down to it. And again, just to go through there, when you have multiple parameters, make sure you understand that it's all respective order. And again, for these functions, they don't much matter. But what if this was division, and this was value 1 comma value 2, and you're like, well, how about which one gets divided by which? That very much matters. The end result very much matters. So you have to understand that probably the first value would be the numerator, and the second value would be the denominator if I were going to divide. Let's see what else is going on. So then, so the return value. So basically, what you can kind of think of, if you're thinking of the way data types work out and all these kind of things, is that for this here, if I'm saying cout absolute value d, essentially under the hood, this function returns a double. So in essence, I'm saying print out a double value and then an endline character, because that's what this thing resolves down to. And since it resolves down to from double in to double out, that's all there is to it. So that in this case, the negative, the positive 9 would be print out of this thing, because that's what comes out of the absolute value function. So the argument would be d, which is negative 9.0, turns into a parameter over here, gets modified, but on this side, but not on the other side, returned back as positive 9 as a double, which gets printed out. Let's see. Boom, boom, boom. Let's see. So so you can call functions. I can call absolute value that doesn't do anything at all. There's no reason to do this. You don't have to take the return value back, but what was the point of doing the function? Some students forget this. I forget this very occasionally. It's like, well, if I call this function, what is it doing? It's setting the absolute value, figuring it out, returning it back, but I'm not doing anything with it. It's basically asking like, hey, what's the absolute value of 2? And then covering your ears when they yell back the 2. It's like, I can't hear it. And so what was the point of asking if you're not going to do anything with the result? So you have to watch out for that as well. So either, like in this case, I'm printing out the value, or in this case, I'm keeping the value stored as a variable. So like, use it in an expression, because I could do, this plus 5. Those are like the 3 different ways I can use this thing, right? So I can, assign it to a variable, send it to cout, or in this case, do both. Use cout and take it and use it as part of an integer expression. Okay, so Boolean values, there's really no difference here. Boolean, true, false. And we haven't gotten to anything where it's really interesting, like arrays and collections of data or anything like that. But I can just say bool is value 9. And I'll say int comes in value. And since I've already, since int or if statements are not the most complicated thing anyway, I can just say, and I'll just do this for simplicity, I'll just say if value is equal to 9, return true, otherwise return false. And the reason why I'm just gonna change this up in a second here, I see this a lot, and I learned this in college, actually. Nobody taught me this in undergrad, is like, well, like in this case, the relational operator always returns a Boolean. Like when I use this value equals 9, it's going to return a Boolean true-false value, and I'm trying to return a Boolean true-false value. So we were just discussing, why waste all this code and even add curly braces and all these other things and else's and all sorts of stuff, when all I have to do is just say return value equals 9. Parentheses are your choice. But this is all that it comes down to it. It's just value comes in, test against 9, return this value. And so let's see, function can return a Boolean true-false value from this. Let's say declare return type in. Yep, of course, declare it as a bool. So then the function body must return true-false, which again, I don't want to get into it another time, but it can be a little tricky between 0 and non-zero values. And then you can use it as part of, it's basically a 0 or a 1 that comes back. And at least in C++, I can treat it like an integer value or a Boolean, depending on what I want to do with it. So they have an is-even function for this. And so is-even, just test the last bit and see if it's a 0 or a 1. That's all you have to do. And so, again, this is very complicated. My goodness, right? This is 1, 2, 3, 4, 5, 6 lines of code, and it could be even more if it uses curly braces. 10 lines of code. That could be 1 line of code, because it just needs to be return num mod 2 equals 0. Just like I have return value equals 9. So just to say, but that's all there is to this function. Int comes in, bool comes out, and so because this is a relational operator, bool comes out, and I can use that. If it is even, print even, and if it's odd, print odd. So that there's really not much I feel I need to really go into with this detail. So as we're saying, these scoping rules start applying, and I already described earlier that when I use a parameter, the parameters go out of scope when I hit the closing curly brace when the function ends. And so, but basically everything else obeys the similar scope rules. If I set up a variable f here, I can use it inside of this function, and again, I can't use it outside, because when it hits that closing curly brace, it goes out of scope, just like the parameter. So you can think of the parameter as the same level as if it was defined at the main level here in the function call. And we've already discussed when it comes to, well, maybe we haven't, when it comes to just, using if statements and for loops and that sort of thing, that I can use it pushing to the right when I'm tabbing over and using everything, but when I fall back, as I've just shown twice here, or at least in this video, when I fall back and I hit the closing curly brace, it goes out of scope. It's no longer part of what I can do. So variables defined inside of the function are local to the function, just like the parameters. And other functions may have separate values. So since value goes away, I could have another function that takes in something, so just I'll just call it void hello, and just pass in int, and I can call it value. That was not it. And so I don't have, whatever, value equals 4. I don't know. I'm just typing stuff just to type stuff, just to have something in there. But you can see I can have the same name in multiple places, And that just falls down to the fact that because the scoping rules apply and value goes out of scope, value dies here, I'm free to resurrect value anywhere I want to, as long, and I don't want to get into more details on that, but just understand that I can have things in different places. And students do get confused, especially with pass by value, pass by reference, which is coming up soon, those two different ways of passing information, and it just comes down to, well, what's getting passed along and how is it being used? And so I'm not even going to worry about global variables because in this class you shouldn't have to worry about that. We use object-oriented programming. There is no such idea in Java as a global variable. We're moving away, kind of away from that idea for the most part. But in C, C++, nowadays in a modern world, we don't need to really worry about global things. And if you want to, here is the description of the lifetime of a local variable. Kind of describes, just a different way of describing the way I described it. So I'm not going to go into the details. You can read it there, pause it, read it if you need to. But again, globals, you can make globals, but I will hit you hard on this one because again, we're not writing any programs that require anything huge. And a global variable would go outside of any function. Just might as well talk about it. Int r equals 3. And global means exactly what you think it means. As soon as I define it here, I can work with it anywhere because we discussed about how scoping rules hit a closing curly brace, but there really is no closing curly brace inside of from a global standpoint because everything else is contained. There's no closing curly brace to end my program. So this thing is global. It exists always, and it exists everywhere from the moment. I can't, again, like everything else, I can't just say int r equals 3 after I've used it. I have to define it before I use it, but now I can go ahead and use it anywhere, and I mean anywhere from here on below. So you can, and that means that since it's global, everyone can access it, and if anybody changes it, then it affects everybody because it's one variable shared by everybody, and that's not always a good thing because you generally want to have control over who is modifying my data. And if someone's trying to modify my data to something that's complete garbage or incorrect, either intentionally or otherwise, I need to have a mechanism to go in and kind of stop that from happening. And say, debug, yeah, say I learned that in 2006 when I was making a game, when I was using all sorts of stuff, just learning the craft. Like everyone else, learning the craft and just going, oh my goodness, this is just unmaintainable. I could have probably been done months earlier on the game I was making if I had just understood all the principles that I understand now. So the only thing I would recommend that you use for globals would be things like constants. You don't want to define constants more than once because what if I define pi differently in one place versus another and I get slightly different results? And that could be a problem depending on the simulation or whatever it is you're trying to run. So const double pi equals 2.141592655. Still don't remember anything more, but you get the point. And now I can use pi anywhere. I don't have to redefine it. So interesting kind of rules when again C++ programming languages are weird things when it comes to all these rules that you're supposed to know. And so global variables by default will get initialized to 0. So like if I have int r equals, or just int r, and run my program, I don't think I'll hit a breakpoint. Oh, I do. Okay. R is 0. Fair enough, right? But if I'm running my program here, and I have my print menu, where's my print menu? And I say int r, or rr, just r, and I run my program now, rr is uninitialized. So globals get initialized, locals don't. That's just the rule. You got to get used to it. And that's what this slide is just trying to tell you. Alrighty. So moving on. So there's an idea of what is called static variables. And so I've written some code here. And you can see basically I have a function called call. I initialize a variable called f. I increment f so that it should be 0 goes to 1. And I'll print 1. And then I try this 6 times over. And so if I run my program, oops. Don't mind all this extra stuff here. Just trying to make this nice on you guys. And so oops, it's not actually stuck. Maybe that's not let me run it again. There we go. So there you go. You can see it goes 1, 1, 1, 1, 1, 1, 6 times over because every time I come in, it initializes f to 0, and I increment it and then I print it out. So that would make sense. It's going to print 1 every time. But what if I could give functions memory? And that's what the idea of static local variables is all about. And so I can set up this f as a static variable. And so instead of having scope that exists only while the function is called, I can essentially give it global. It's essentially global. It exists always, but it only can be used inside of this function. So local variables only exist while the function is executing, and when it terminates, the contents of the local variables are lost. That's just general local variables, right? We're just showing that. I incremented f from 0 to 1, and then it fell away and it died. But if I put static in front, that changes everything. And now this function has a memory, and it is kind of weird, and now you can see it actually prints 1, 2, 3, 4, 5, 6. Because what happens is, the first time I hit this line of code, I initialize the value to whatever it is, in this case 0. But every other time I hit that line of code, I ignore it. And so in this case, the first time through, I set it to 0 and increment, and I print the 1. And then forevermore, you can consider it like being commented out. And so forevermore, it's a little weird here, but because of what I'm trying to do, but you get the point. F now exists, and when I increment it, it's now 1, which gets incremented to 2. It's 2, which gets incremented to 3. And so forth and so on. And now I'm confused. Let's see. What does it do here? Does it initialize statics or not? Right. So let's see. Oops. So for whatever reason, since they're basically they're kind of in between, right? They're locals, but they're globals at the same time. But when it comes to initialize versus uninitialized, they do get initialized to 0. That's what we just showed here. So they show local, return. What are they doing here? Let's see. The local variable is 5, and local is 99. Notice, whatever, 5 becomes 99. But what happens if I run a loop? Oh my goodness, what are they trying to do here? Make it static and increment. They're doing exactly what we're doing here. Starting with 5, incrementing it, just starting with a different number. And you can see then static int 5, print out the value, then increment it. They just increment afterwards instead of before. But 5, 6, 7, 8, 9. And again, this because it has memory. But I can't use f anywhere else. It's a global inside of the function, but it's local to the function. It's semantics. It's kind of that hybrid in-between zone. Okay, default arguments for functions. So let's see. So I can actually set up, we haven't really discussed function overloading and stuff like that, but I can go ahead and say there are default arguments for parameters. Because what if, and this is just kind of weird, what if I wanted to do my absolute value function, but not pass in anything? I know, let's just go with it, right? Let's just double J equals absolute value. And of course, this gives me a compiler error because the absolute value function requires a parameter. Down here, it requires this. But what if I could set it up, and they say this is a poor example. They have even or odd, and get sum and things like that. Oh, that's kind of interesting. I like this one. Yeah, let's do that instead. This get sum function. I'll use A, B, and C here for the 3 values. And so I want to return A plus B plus C. Simple enough, right? I like this idea over my absolute value. My absolute value idea is crap. Okay, so, but what I can do here is, at this point, if I wanted to do that, do a cout and use my getSum, I would have to put all 3 parameters in. And what if I wanted to, so make this more flexible? This requires me to put in 3 values. What if I made 4? This is where the fun of programming, fun is in quotes, is relative, right? So I say, okay, 1, 2, 3, 4, that'll print 10. But what if I only wanted to add 3 numbers together, or 2 numbers together, or maybe just 1 number together? So what I could, or even 0 numbers together, and just get 0 out of the deal. I can supply what we call default arguments, default parameters to this function. And now everything should work out. And now actually I can go, it'll work fine for this, But now I can actually go in and set things up like this. And what happens is the compiler looks at what you've supplied, and it goes, okay, the 1 will go in as A, the 2 will go in as B. So it overrides the default behavior. But for C and D, I did not define them, so the compiler will fill in the zeros for me. And so this will print 3, and this is perfectly fine. So now instead of writing 4 separate functions that can handle a get sum of 1 and get sum of 2 values, 3 or 4, it's one function, still one line of code, and I can supply 0 parameters, 1, 2, 3, or 4 parameters to get the job done. I think that's pretty cool. So that's the whole idea here. So in this case, display stars on the screen. I can have a default that is 10 and 1, whatever that means according to this function, 10 columns, 1 row. And so that's the default. If I don't supply anything to it, it'll do 10, 5, 10, 1. And in this case, it'll do 5, 1. So there's 2 parameters, and I don't have to supply. And so this is kind of cool. I can do 7 by 3. So I have a loop here, which would maybe depending on your class you haven't taken. So I want 7 3 times over. So here is 10 by 1, here's 5 by 1, and then here's 7 by 3. So I can supply 0 parameters, 1 parameter, or 2 parameters, and the function behavior essentially changes based on those results. I think that's pretty cool. And so the only rule is for this is that any default parameter has to go at the end. Because what if I tried to put something like this? I've got int, 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 and I go, oh, let's just make the C required. Well, how would that even work? Because if C is required, then I need A and B. So then why would I have default values for A and B if C is required? Because then A and B are required. And so you can kind of see, you can kind of work the logic back from there. And you can see that I can only work from the back. So let's say I can get rid of default parameters, but I have to start from the back. And that generally is pretty cool because you can give a default behavior for a function, and then you can add like a more optional advanced feature, and you can kind of turn it off until someone wants to use it. And that sort of like this, like if I want to just print more than 1 row, I can do it. But by default, I just want to print 10 asterisks or whatever it is that's going on here. Okay, pretty cool stuff. All right, so we already talked about pass by value. Let's talk about pass by reference. We already showed how pass by value works because again, I go to that copy machine, and now 2 copies. I give you 1, and I never expect it back, and then you can do whatever you want with it, and it doesn't affect me on the other side. But now, as we're discussing, reference variables are completely different, and now I go ahead and give you the real data. I give you the master copy, and you're still free to do whatever you want with it, and then you're required to give it back to me when you're done, and then I just take whatever you did. That's kind of what this is. That's what reference variables are all about. Everything you've seen today so far is pass by value. Even though this is default values, these are all pass by value because it's just plain old ints staring at me. So just to repeat here, this idea of reference is a mechanism that allows a function to work with the original argument, like the master copy, and not a copy, a secondary copy of what's going on. So it allows the function to modify values stored from the main or whoever's calling. And it actually also provides a mechanism. This comes back to the old C-style stuff too. It provides me a mechanism to basically return multiple things from a function. Because as we were discussing earlier, a function has to return only one thing or 0. Void is 0. But int or float or short or this or that. But this allows me a mechanism to technically, not truly, return more than one value because I'm allowed to modify more than one value inside the function and have it return back. And so I use the little ampersand for this. So let me set up a function. I'll call it, make it a void function. I'll call it pass by. And I'll pass in 2 things. I'll pass by value and I'll pass by reference. Okay, and notice the little ampersand there. That little ampersand means all the difference when it comes to all of this that we're going to discuss here. Okay, so I'm going to create 2 variables. I'm going to create, maybe not A and B. I'll create I'll do AAA equals 3, int BBB equals 5. And what I'm going to do is just print out AAA, print out a space, print out BBB. Whoops, you get used to doing 3 at a time. And then do an end line. And then I'll call the function I'll say pass by. I'll pass in AAA and BBB. And I'll print everything else out again. And up here, what I will do, just to kind of show everything going on here, I'll print out value. I will do a space. I'll print out reference. I'll do an endline. And then I will just blindly change values. Value is 91 now, and reference is 62. And then I will print everything out. So there's going to be 4 prints. Let's make this so everyone can see it. There we go. So you can see there's 4 prints to this. I'll print here, call the function print, change stuff, print, come back, and print again. And so let's just show the values, show what pops up. And so, okay, so 3, 5, 3, 5, 91, 62, 362. That seems very, very confusing. So let's step through this. So what is happening here? So I'm setting A to 3, I'm setting B to 5, and then I'm printing that out. So the first print statement makes total logical sense, 3, 5, because that's what's stored here. And then when I do pass by, 3 and 5 are getting copied. I was like, the 3, AAA, is a value type. So it is getting a copy of the 3, and it's getting passed along here. Okay, and now the BBB is a 5, but instead of the copy machine effect, it's getting the real data. So it's getting, so we're passing information in 2 different ways. It doesn't feel like it, but we are totally doing that. And so I'm passing a 3 and a 5 along using those 2 different methodologies. So there's a 3 stored inside of value and a 5 stored inside of reference. So now when we get to the C out here, you can see it's the same print statement because I haven't really changed anything. I've passed the 3 along, I've passed the 5 along, and I'm printing out their values. Fair enough. So 3, 5, 3, 5, that's perfectly good. Now this is where things start to get a little mind-melting the first couple times you think about it. And so what happens now is I change the values, 91, 62, and again, now you go ahead and print out, and it should be exactly what you think. It should print out 91, 62, because I changed value, I changed reference, and then I just printed out their changed values. But again, up to this moment, nothing really stands out, except for this little ampersand again. You're like, where does this thing come into effect? And it finally comes into effect when you close out, return back, and do the final print statement. Because what happened again was, I went for AAA. I went to the copy machine. I made a copy of the 3. I'm holding on to the 3. I gave you the 3, which you slashed out, turned into 91, and then did stuff with it. But when everything came back, and now it's my turn, I'm using the original master copy, which is still holding the 3. And that's why it prints out a 3 for value. And so now when it comes down to it for reference, well, what happened was this little ampersand means that I took the 5, and instead of making a copy, I held up the little piece of paper, or I handed you that piece of paper, the master copy, and then you went ahead, slashed out the master, slashed in a 62, and then handed it back to me. So now over here on this end, when I went to print out the value, the 5 has been slashed out, and it prints out the 62. And that's what reference is all about. And at a technical, the technical level, this passes a copy, this passes a memory address. This little ampersand generally stands for memory address. Not always, but generally stands for memory address, which is basically a pointer or just where in memory is a specific value or variable stored. That's essentially what's going on here. And so this might talk a little differently about it with the PowerPoint slides. The book might talk about it, but that is the gist of what's going on. And there's 3 total ways we can pass information to a function, and we've already handled 2, and I say 3. The third one is like a 2.5, and that is, we call that pass by pointer, and you will see that in a future video. It's basically almost the same. There are differences between references and pointers, but they're kind of at their core the same idea, and the syntax will be different between how do I use a reference versus how do I use a pointer. Because notice, even with this little ampersand, my syntax has not been modified. Everything has been used exactly the same way, whether it was a value type or a reference type. And you will see that in Java, C#, C, you name the language, those other languages, Python, value types, reference types. There's no, you don't see that little ampersand. As a programmer, you just have to understand what's getting passed along. Okay, so they have a value. Here we go, int reference that's being passed as this function called double the number. So a value comes in, it doesn't, so this is a contrived example because this is a better example for just returning an int that is returning the value times 2. This is just showing you that you can do things this way. This is not showing you should do things this way. But just to say, okay, that little ampersand means everything. Because if I don't include that, then I'm modifying the copy, and the original value will never be modified. So in this case, this will change. Whatever I pass in will be modified and be doubled. And so that's it. So let's see. Each reference parameter must contain the ampersand. Notice, I do not use this on the main side. You don't see any ampersands over here. I just see it one time here. And I have to, if I use it if I have a prototype, the ampersand is part of the prototype. Some people I like to put the ampersand by itself. Some people like to put it over here, and there's a special layer of hell, for these people that put it. I'm just kidding, but you can put it kind of anywhere you want as long as you put it before the variable name. But basically sandwich it between. Nope, I've never seen that. I've never seen that in my life. Don't be the first. But I personally do this. The IntelliSense or the formatting, and I haven't modified it. It actually fixes it up and does this for me. I'm okay with whatever you want to do. So what's interesting, though, is I cannot pass along, when it comes to the reference variable, if I want to say pass by 6, 7, you will see pretty quickly that I can pass the 6 along just fine because of the whole idea of the copy. I'm making a copy of the 6 and passing that along to you, so you don't notice anything weird about it. But when it comes down to it, I cannot pass a memory address to a literal hard-coded number because there's no memory address for the number 7. And so I have to pass in a variable or a memory address of some sort when I use a reference. So that, it has to, that's why it had to be AAA or BBB. I can make BBB 7 and pass it along like this, but a reference requires me to find a memory address to be able to modify. All right, so that covers that idea of pass by value versus pass by reference. And the idea of pass by reference and then also pass by pointer becomes a huge deal in advanced C++ when we're dealing with pure object-oriented programming, polymorphism, inheritance, all these 4 or 5 syllable words. Very big deal when it comes to it. So there's a lot going on in this chapter. There's a lot of new topics here, things that you might not expect, but we're almost done here. And so another one here is this idea of overloading functions. So before templating was involved, this was the cool way to do things. So I can overload a function, and the easiest one to think of here is this absolute value function. So let me pretty this up a little bit, get us ready for this. So overloaded functions can have the same name, but different parameter lists. Because what if I wanted to have, like we're discussing, what if I wanted to have a float value and an int value and a short and a long, like different types for this absolute value function? Well, you might think that I'd have to have absolute value double, and then I'd have to have absolute value int and absolute value short and so forth and so on. But you can prove it that you don't have to do things that way just by putting abs in and then just putting a parenthesis just to see what IntelliSense shows me. And it shows me there's 6 different versions of the absolute value function. And you can notice they all have the same name. So input int, output int. Input long, output long. Input long, long, output long, long. Input double, output double. Float, float, long double, long double. So 6 different ways to go about doing things. And they all have the same name. And we can do the exact same thing. As long as the name is the same and the parameter list is different. So this is all I have to do. And I don't have to change any of the code. And that's where the idea of templating becomes a bigger deal in advanced C++, because why should I write this code multiple times and the only difference here is the data type? The code is identical. And for all 6 different versions of it, the code would be exactly identical. And so the same task is being performed, but different parameters are involved, and the compiler will figure out which version to call. And so I can prove that. Oh, this is part of the fun here. I can always say the compiler will. Well, I'm alluding to that already. How about this here? So I say float e equals absolute value of 4.3 float. and I say float, I don't know, I'm just making up, how many letters have I used today? 4.3. So this 4.3f is a float, this 4.3 is a double. And so what happens if I compile this, build this? Oh, you get warnings. There wasn't an error? I thought, wait, this thing is screaming out. Oh, this new system is fun. It succeeded, but this is definitely not good practice. So initializing, conversion from double to float, possible loss of data. And this is where the tricky part comes in. I just told you that it knows float, float, double, double, but it sometimes it doesn't know. It's doing its best to try to figure out what to do. This line of code, this line of code. Oh, this one should be double, sorry. Probably screaming at me earlier when I did it. And so that fixes those up, I believe. Oh, maybe not. This is a problem. This is a problem. Oh, that's completely different. And then that's a problem. And this isn't even giving me an error. That sucks. Okay, but so it comes down to it. Let's bring this up here. Let me do it. Yeah, let me do it this way. Int p equals absolute value of 4. So we and then doing it again. But if it runs, at least we can get an understanding of what's happening. So let's run the program and see. The compiler is doing its best, and it says I'm at this line of code. If I hit F11 to go into the function, it goes to the double version. That is weird. Why is it doing that? And again, that's part of C++. Even though I slammed an F in front of this thing, I guess it doesn't know that it's supposed to call. Oh. 4 minutes of code. Anyway, okay, so I think this is a learning example. Normally I would stop this and start over, but I think this is a pretty, I've never done this before, so I think this is actually stupid, nerdy fun, this error message. Like, what is going on here? Why is it going to the double version? I'm used to say, when you're used to object-oriented programming, these little tiny things come up occasionally. This is fun. This is definitely a new one for me. So what happens is I hit F11, it goes into the double version, but it's a float. We just showed that. And so double X, there's my my 4.3, I go in, it does what it's supposed to, E is 4.3, blah, blah, blah. But if I use the double version, it goes into the double version. Okay, fair enough. And now if I go into the int version, it goes into, wait, did I hit the right? Did I actually hit the right bed? Oh, wait, okay, yeah, when I go into the int one, I go into the double one. They're all going into the double version of that. And so, are you understanding why? It took me a minute myself, but I get it now. And so, even though that's, I don't know why it comes up red. It shouldn't come up red then. It comes up 4. But every one of these is calling the double version, even though I've defined the double version and the float version. But what it comes down to is, this is a weird thing, because normally I put all the functions above the main. This is why this to me is so weird. But when it comes down to it, these function prototypes, remember the function prototypes we set up way back probably 45 an hour ago? And well, what happened was we told the compiler that there's going to be a version of absolute value called double that has a double in and a double out. We never mentioned any other functions, even though they exist. When it gets to it and the compiler gets to these 3 functions, all it knows about is what I told it up above about this absolute value being a double in, double out. It never even thinks about the fact that there's a float version sitting underneath. It just doesn't even cross the compiler's computer mind. And so to change everything up, this might now cause an error. I'm hoping it causes an error because if it doesn't, it's still a warning. But now if I build this, what happens? Of course I want to stop debugging. What happens now? Oh, now a whole ton of stuff goes wrong. And now I've told the compiler that there are 2 different versions. We've overloaded that operator. We've overloaded this function here. There's a double version and a float version. And so what is it screaming at me now? And so it's not screaming at me about the float version or the double version, because it can infer that this is supposed to be the float version of absolute value. This is supposed to be the double. But now when it comes down to it, this one right here, there's an int, because there's no integer version of it, right? All I have is double, and all I have is float. And so when it comes down to it, there's 2 completely legitimate options for the compiler to make to convert int into. It can convert int into float. It can convert int into double. It's not going to guess. And that's what's going on. It's an ambiguous call to an overloaded function. And so, oopsie, right? So if I needed to do something like this, I need to convert the 4. I have to convert the 4 from an int into something else, or I have to generate the integer version of the function. So, let's say one way to do this is to static cast the 2, or like if it was a variable. If it was a variable, let's use another one here. Just use int g equals 2, and say I have to static cast into float. I want the float version of g. And remember, static cast is a temporary thing. Did that fix everything though? Oops, that probably fixed the 1. Oh my goodness. That probably fixed the 1. There we go. That probably fixes the 1 but doesn't fix the other. Because nope, never, not that. Oh, what in the world? Where did I do it? Oh, I did it down here. It's the same deal. Oh my goodness. It's been a long morning already. Huh? Okay, so that's static cast turning the 4 into a double or something like that. So it's tricky. I say it's something you never think of when you're using a calculator because the data types just automatically get converted. You don't even think about this in Python. The newer languages, this is all just dynamically generated for you. It just handles it. But again, because it does things automatically for you, sometimes you get the results like this. You get the results you're not expecting. And so now, a minute ago, everything was double all the way around, but now the float value gets called because now it knows that that value is a float and it knows what to do. And then it goes into here and go, okay, now the double version is called. And then because I've used the double version here, it goes into the double version. And then when I work my way down, wherever it is, it knows, come on, where are you? Here we go. It knows to use the float version because I specifically mentioned that it needs to be a float. And so again, the big deal is, so the other option was to just create the integer version of this. And then remember the prototype so that you can tell the compiler that this is an option. And now for that, oops, I don't have it now. But now coming back, if I get rid of this and bring it back to how it was originally, which is plain up 4, this will compile just fine and run just fine because now we're using the integer version of that function. All right, so 10 minutes to discuss this. But again, I would have made it simpler except for the fact that it's a learning opportunity for me and for you because we don't often see that because a lot of times you don't use function prototypes, especially in object-oriented programming. So the only thing here, the names are the same, the parameter types are different, but the return types are not part of that signature. And so you just understand, just one last little thing here, I can't do something like this where I have name, data, the name and the parameter list is the same and the return types are different. So you just can't do it. Cannot overload functions distinguished by return type alone. So the compiler will not do that kind of distinction for you. So I can get rid of this. So you just have to watch out that the only thing that matters, the name has to be identical, but the parameter lists have to be different. So they have different here for square values, an int value and a double value. But again, at the end of the day, it's returning this. It's doing the same math. So this screams out templating, but that screams out advanced C++ for sure. Don't need to talk about that, and I don't need to talk about this. But well, maybe I do. But just to say, as we move forward, is there's like stubs and drivers and writing your code. Your main code, the main function, as you get more advanced, should become more human readable. This is not a good example because we've been just showing you examples. But as you move on, the code, you should, while, I'm just saying, while some object is not done, do something. Just to say, this is kind of what, of course it's going to give compiler errors to all holy heck, but something like this is say it's going to become more human readable than the absolute code because you're putting the code to do the work into a function call, that has the name of the thing it's trying to do. So you're removing a lot of the details. Your brain is calming down because it's not thinking of thousands of things at one time. It's only thinking of tens of things, I guess, or however, ones or tens of things at a time. And if I need to delve deep in, I can go into that function. Otherwise, I don't have to worry about it. So it's a top-down design. It totally is. We're taking a large problem, breaking it into smaller pieces. Take those and break those down until we finally have every one of these ideas from that one big idea is a manageable chunk that all works together in the end. That's the whole idea of what we're doing as programmers, and we're trying to do it with the least amount of work as possible, because so many, as you're noticing, so many little things can go wrong. And all it takes is one little thing to go wrong to just snowball the whole process. And that's what the idea of stubs versus drivers is all about. All right, so long video lecture that covers everything that's important. The main topics here are the pass by value, pass by reference, and just understanding how to set up a function and create a function that does one thing and one thing well. So that was 1 hour and one sentence there. So if you have any questions, if I misspoke about anything, as always, swardb@cod.edu. Get a hold of me there. Just put a comment here in YouTube. I'll get back to you as soon as I can. So let's say we're done with functions. So depending on where you're at, we're either going to move into if statements if you're in engineering, or we're going to move into arrays if we're talking about the class for majors, the first C++ course. Thanks, everybody. Have a great day.